Okay, so in this video we're going to take a look at, we're going to study what are called arithmetic sequences. So let's say that I have two different sequences. And the other one we'll define as 1, 3, 6, 10, 15, etc. Alright, now an arithmetic sequence is a specific type of sequence that has a relationship with the amount or the value that is getting added or subtracted from one term to the next. Right now, if we notice here, to get from 1 to 3, we added 2. To get from 3 to 6, we added 3. Then 6 to 10, we added 4. And here we added 5. So we can see the pattern that is arising, right? And now this type of sequence, this is not an arithmetic sequence. The value that we're adding is changing at each step, right? It's its own type of sequence. Now, if we contrast that with this here, right now in here, we have minus 2, minus 2, minus 2, minus 2. Okay? All right. Now we have a specific type of pattern here where at each step of the way we're taking away a fixed value. All right. Now with this fixed value that we're taking away or sometimes adding, right? It doesn't have to be necessarily subtracting. This is what's called the negative 2 is what we call the common difference. Right? And what we find it is we take whatever term we're at in our arithmetic sequence and we subtract it from the previous one, right? So 16 minus 18 equals negative 2. Right? 14 minus 16 is equal to negative 2. All right, and we can see why we call it the common difference, right? It is, you take the difference between a term in a sequence and its previous term. If this term is always the same, as it is in this case, then that is what we call an arithmetic sequence. And another way to think of this arithmetic sequence is if we have our first term here, and then at each step of the way, you're adding the common difference, right? So you can all write it with reference to the first term, right? Now for the first term, the second term, you add one common difference. Now notice here, for the third term, you're adding two common differences, right? That happens twice. And then for the fourth term, you're adding, in this case, 1 to the 3 common differences, which is a negative value, etc. Right, so you can think of this as a way to find our nth term, right? As you can see, now I have a general formula. Okay, and writing terms here, so we have an explicit formula. An explicit formula for arithmetic sequences. Okay, so we know that an will be equal to, right, our first term, which we can use as our reference, and then here we're adding some common difference. Now it depends where we're at along the sequence. Now notice here that if this is A1, A2, A3, A4, the number of times is always one less than the nth term that I'm in, right? In this case, the fourth term, the third term, the second term, they're always, the common difference that we're adding is less by 1, right? So when we write this here, excuse me, what we're going to multiply that is n minus 1, right? So as you can see, when a sub n is 4, right, then here 4 minus 1 will be 3d, and we get that value here, right? When n is 3, right, we get 3 minus 1 is 2, right? So it matches up with our pattern here. Right now, in terms of the above sequence here, to find the explicit formula, right, A1 is 18, as we see there, And again, n is our variable, so it stays n. And the common difference is -2. All right, and we can do a little simplifying here, right, to write it here, 18 -2n plus 2, and we get a sub n is equal to 20 minus 2n. All right, and here now you have a explicit formula for n greater than or equal to 1, and again, n, when dealing with sequences, it's implied that n is going to be some integer. All right, and you see here just a quick mental check when n is 1. Right, this is 2. 20 minus 2 is 18. When n is 2, 20 minus 4 is 16. So we see it does match up with our sequence there. Okay, so let's try an example here. So let's say that we're given that A3 is equal to 7 and A5 is equal to 17. Find A2 in an arithmetic sequence. All right, so here the best approach here that I like to do is just to find the explicit formula. That way when we do find the explicit formula, right, I can just plug in the 2 and find whatever A2 is going to be. All right, now one way we can do that is, okay, now I know the explicit formula. Okay, so I know both of these, right? A3 and A5, so I'll write the explicit formula in terms of 3 and 5. Right, so doing a little simplification here and substitution, right? A3 is 7, A1 plus 2D, A5 is 17, A1 plus 4D. All right. Okay, now here we have a little system of equations. I think the best way to do here is let's solve for D by subtracting the bottom one from the top one, and in doing that we get, right, so 7 minus 17, negative 10, negative A1 minus A1, that goes to 0, right, which is what I want, right? I want to eliminate one of these variables. And then 2D minus 4D is negative 2D, and now we can easily solve for D. Divide by negative 2, we get 5 is equal to D, and I found my common difference, right? And to find A1, I'll take the first equation here, so 7 equals to A1 and D is 5. Oh, excuse me. 7 plus 2 times 5. So we get 7 is equal to A1 plus 10. Subtract 10 from both sides, and we get A1 is equal to negative 3. All right, so now we have our general formula to be A1 is equal to negative 3 plus n minus 1 times 5. All right, for our common difference. Now doing a little simplification here, we get plus 5n minus 5. Okay, so we get this value here. All right, so that's our explicit formula, and now we're asked to find A2. Plugging this in, we get A2 is negative 8 plus 10. A2 is 2. All right, and that is how we can solve this problem.